Hi friends, is my voice is audible to you? My voice is audible, and if everything is fine, please let me know. Right? Okay. I just want to check how many of you guys are in online. If you are in online, please say hi so that I will understand. Okay? Right. Okay. Please say a hi so that I will understand you people are in online. Okay? Right. Today's I just want to say first a very big hi to all of my brothers and sisters who are on the online. So today's session is all about summary of IS 456 2000. We will tackle about the clauses of shear using objective questions. So whatever may be the shear concepts in IS 456 is there, we are going to tackle that using objective questions. Okay. In your previous class, I completed all the numerical questions that are there on shear, right? The remaining theory clauses that were there on shear, we are going to tackle for this session. Before I start the session, I just want to convey one more thing. There are so much of free content is already happening in this Unacademy learning app. If you are a serious aspirant of GATE or ESE or any other competitive examinations, okay, then I can recommend you to install this Unacademy learning app, brother, because you can get at least some good free content, at least you will get. And if you want to follow me in the Sun Academy learning app, you can use the link which is given below. If you are able to use this link below, you guys will be redirected to my page. And when you are able to follow me, whatever may be the free content that I had done for free of cost in An Academy learning app, you are able to access. And the future coming free videos of mine will be notified to you. And at the end of each and every free session, we are going to provide free notes to you. All these things you are getting for free of cost. This is the advantage when you are able to follow me. It will not take even a single paise also. And some people say like, sir, is there any paid content? Is there paid courses are there in an academy learning app? Yes, brother, there are paid courses are also there. Select your target as gate and select your goal as gate and ESC, and there will be a main drop down menu. In the main drop down menu, you go to plus courses. When you go to plus courses, you are able to see a tab called get subscription. When you press on this get subscription, you are showing your interest, like you are interested in the paid course for the complete course of gate or ESE or any other competitive examination. So in such case, there are two courses are available for paid things. One is plus course and iconic course. So when you had taken these paid courses, India's topmost faculty will teach you. Right. Direct instant doubt resolution is also there, and you will be provided with the recorded versions also when you are with in the form of maybe mobile phone or maybe a smartphone, and you will be provided with the help of test series also, and we will provide the entire plan. So there are so many advantages are there when you had taken this complete paid course, right? So all the things will be given in the form of recorded version also. If you want to get 10% discount, some people generally ask for, sir, is there any discount is possible? Yes, brother, when you use this code VT10, definitely 10% discount you are going to get on all the courses like plus or iconic courses, anything you are going to get 10% discount. Moreover, when you use this code VT10, directly it shows your trust on me, it shows your faith on me, it will directly connect between you and me. And there is no need to go to Delhi, there is no need to go to Bombay. The topmost faculty of India are right now available at your doorstep, just with the help of using single code called VT10, right? Some people say, sir, this is my first class. First of all, please introduce yourself. Okay, let me introduce myself, brother. I am Venkata Tilak. People call me as Venkata sir, some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree. My background of education is completely into structural engineering. So here also in an academy, I am going to teach only the structural engineering subjects, ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction methods and management. These six subjects I am going to tackle. Coming to this university from where I had graduated, some people will also ask us, sir, what's about the specialty of this university? This university produced six Nobel Prize winners, brother. So you can understand the research potentiality involved in this university. And moreover, this university's ranking is always far better than IIT and IIC Bangalore. This is not told by me. This is advocated by different ranking agencies globally. The ranking of this university globally is always less than 100. If you see, coming to my previous work experience other than teaching, previously I worked as a research scientist or research engineer in University of South Carolina. This is in USA. For the funded project, I worked as a research scientist. Moreover, previously I worked as head of the Department of Civil Engineering in an engineering college. This is in India. That means I have both within India experience and global experience also. Coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Being a structural engineer, even till today, I am working as an independent structural design consultant. I personally give structural drawings to my clients, and I personally give material testing reports also to my clients. This is the work generally I do in personally, in addition to teaching. Some people will say like, sir, okay, one second, brother. Yeah. Some people will say like, sir, this is fine. Now, can you tell me with the help of screenshot how we can take the paid course, right? I hope after you install this Unacademy learning app, you can select your target as GATE and ESE. And in this main drop down menu, go to plus courses. After you go to the terminology called as plus courses, you are able to see a tab called get subscription. Right, when when you press on this get subscription, you are able to see whether it is the whether the course is whether the course is iconic or plus. You can take any of these courses. Now some people will say like, sir, how this iconic course, how we can see that one, sir. And I hope this is how in this screen you are able to see how the app will be, the features of the app, everything, the test series and all this stuff, you are able to see it here, right? And I just want to show how the screen will look like when you select this get subscription. This is how the screen will look like when you take when you see the get subscription. There are two things are there, either plus codes and iconic codes. This in this plus codes, if you had seen, when you use this code VT10, definitely 10 percentage discount will come to you. Just type here, have a referral code here na. In the referral code you type this name VT10, then definitely 10% discount will directly come to you on all the courses, right? From this cost to this cost, the cost has got decreased. So you can understand the importance of this using referral code, right? And I can recommend this 12 months course to the students who are in final year, whereas I can recommend this 24 months course to the students who are in third year and second year of BTech, right? Some people will say like, sir, what about iconic course? So coming to this iconic course is also a paid course, but it is somewhat superior. In iconic course, other than plus course, in iconic course, you will be given with the separate notes separately by an academy, and second, you will be given with a personal tutor, personal mentor. The personal tutor or personal mentor will track all your performance, and he will resolve all your doubts separately, right? That is the use of iconic course. And in iconic codes also, if you want to get 10% discount, use this code BD10. Then definitely when you use this code BD10, directly 10% discount will come to you. This is the cost before discount. After discount, this is the cost for 12 month subscription for iconic code. Like that you can see, right? Some people will say, sir, what are the advantages, sir? Okay, sir, one some people will also ask us like, sir, is there any way how we can follow you, because we want to follow you also na. So if you want to follow me, you install this Unacademy learning app. So after you install the Unacademy learning app, in this main menu here, go to free classes. When you go to free classes, and here in this in this search button, you type my name, uh, Venkata Tilak Uppalapati. When you type this name Venkata Tilak Uppalapati and when you press enter, my profile page will be visible to you. When my profile page is visible to you, you just follow me. This is the other way how you can follow me in a manual way. With the help of link, you can use this link and you are able to follow me. There are two ways that you can follow, right? Yes. Some people will say like, sir, what are the advantages if I had taken the paid course or get subscription? The first and foremost advantage is instant doubt resolution is possible in the daily live classes. You can directly chat with the educator and the educator will resolve all your doubts with the help of poll. That is the first and foremost advantage. In order to crack any sort of competitive examination, the student must and should be supported by test series also. So here also in Academy, we are supporting you with the help of test series. So you can write online tests, online quizzes, mock tests, daily wise tests, grand tests, and you can understand at what level you people are in terms of performance when compared to the topmost students of an academy. And you can definitely improve your performance by working more number of hours in the topic where you are not comfortable. That is the second advantage. And coming to the third advantage is there is no need to plan yourself, brother. We will provide the entire plan. If you follow the plan that is provided by us, even the lectures duration and everything, number of hours, even the timetable, then definitely we are pretty much sure like you are able to crack any sort of competitive examination, because we provide the test series and the number of lectures in such a way that even the below average student can cope up with our lectures and the test series. That's how we plan. And coming to the final advantage is you will be provided unlimited access to all the lectures in the form of recorded version, maybe through maybe through a mobile phone, or maybe through a PC, or maybe through a tab, depending on your comfort. These are the advantages when you had taken the paid course plus or iconic. These are some of the topmost indicators that we have. You can have a quick look in the app itself. And I just want to convey one more thing. There won't be any language barrier for you guys. Those guys who are comfortable in English, they can listen to English classes. Those guys who are comfortable in Hindi, those guys can listen to Hindi classes. There won't be, if the class is in English, the entire lecture will be taught in English. If the class is in Hindi, mostly it will be taught completely in Hindi. So there won't be any language barrier. So you guys are comfortable with your language and you can crack the examination pretty well. So there won't be any language barrier also, brother. And coming to in GATE and ESE, till now in civil engineering, we people had launched almost 8 courses. Out of these 8 paid courses in GATE and ESE in civil engineering, few courses are long-term courses, few courses are short-term courses, I can say. Few courses are in English and few courses are in Hindi. When you had taken this subscription for 1 year or anything, in that subscription you will provide access to all the courses that were launched before, that are going to be launched within the duration that you had taken. You will be provided access to all the courses of your stream, brother. Right? That is the major advantage when compared to other platforms. And one more thing is every day my class is happening in this. Let's Crack Gate and ESC Civil YouTube channel. My class is happening by 11 a.m. So don't forget to come down to my class, and I can recommend even Kamlakar Sir Pandey's class also. His class every day is happening by 9 a.m. So you can have a look at his class also. These are for free of cost. Now you can say the same thing to your friends. Last but not least, you are getting all this for free of cost. Please share these videos to your friends also, so that they will also get benefited, right? And please like our videos, share our videos. Don't forget to press the bell icon. When you press the bell icon, the future coming videos in this YouTube channel will be notified to you. Please subscribe to our channel right now, and please press the bell icon. And moreover, for your convenience, I already started a Telegram group for you guys. This is the name of the Telegram channel, and this is the name of Telegram channel. If you want to come down to this Telegram channel of Let's Crack Gate and ESC or Unacademy underscore Civil Engineer Tilak, you can use this link which is given below. Then you guys will be redirected to our Telegram channel. You can post your doubts there, and we are able to take care of your doubts when you are able to post your doubts there in this Telegram channel. Right. So shall we start the session, bros? I hope you are able to see this question, right? So moving to this question, right? Uh, so please say hi if you are in online. Okay. Hi Vasant Sai, how are you? Hope you are fine, right? Uh, yes. For a reinforced concrete section, I hope you are able to see. Uh, Right, Kaushal Odar. It's the name of the it's the name of the college, brother. So don't forget. Don't be worry. 10 is the name of the college, Sai Tirumala NVR Engineering College. That's the name of the college, brother. So I don't want to mention that big name. Just that's the reason why I had made it in a shorter way. Okay, Kaushal Odar. Is that okay, brother? Right. Okay. Right. Right. Can you see this one for the reinforced concrete section? To take a reinforced concrete section, the shape of shear stress distribution. How the shape of shear stress distribution for a reinforced concrete section is there? They are not talking for plain cement concrete, brother. If you take for plain cement concrete, it is a PCC. In such case, the distribution of shear stress across the depth will be in the form of parabola, both above the neutral axis and below the neutral axis in case of PCC. How we can work out the shear stress distribution? Q is equal to VA y bar by IB, right? This is in case of plain cement concrete. Let us suppose if I had taken a section of reinforced cement concrete in this way. Maybe this is the cross section with the reinforcement I had taken, and the loads are flexural loads. I hope you know the concept of in case of beams, the concrete in tension zone is neglected, right? So I just want to show you the concrete which is in tension zone. I hope you can see concrete which is in tension zone. Concrete in tension zone is neglected, right? Is that okay? And concrete in tension zone is neglected, how you can work out is VAY bar by IB. So above this level, from here to here, if you see, this is how the variation of stresses will be from this layer to this layer. The variation of stress will be just like that of parabola from this equation. VAY bar by IB. What is V stands for the shear force acting on this cross section. Hang on. Section. And what do you mean by AY bar, brother? AY bar stands for at what level you want to work out the shear stress. At that level, take the moment of if I want to work out the shear force, shear stress at this level. Above that level, for that area, I want to take the moment of this area about the from neutral axis. So that is this is A, and this is Y bar. So AY bar is first moment of area, first moment of area above the level where I want to investigate shear stress, and the moment of area should be taken with respect to neutral axis, right? And moment of area can be taken, should be taken with respect to neutral axis. So this is how. So I hope everybody are comfortable in drawing the shape from here to here as parabola. I hope when this is the neutral axis and this area is neglected. I hope this area is concrete in tension zone. Concrete in tension zone is neglected. Only I can take the tension the area of steel in tension zone. Only this is to be considered. So I hope you can say from here to here I can say whatever may be the shear stress that was there, the same shear stress I am going to prolong it till this tension zone still. This is how I can prolong. So you can see the variation of the shearing stress is above the neutral axis it is parabola. So below the neutral axis till this tension zone still till the tension still it is just like a rectangular variation, right? So I hope you can say like parabola above the neutral axis. Yes, parabola above the neutral axis and rectangle below the neutral axis. Yes. So I can say definitely like option C will be the correct option for reinforced cement concrete. Whereas for plain cement concrete, I can say it is completely parabola all above the neutral axis and below the neutral axis. For plain cement concrete, for single type of material, it is a parabolic variation. Is that okay, brother? Can I move to the next question? Bros, moving to the next question, brothers. I hope you are able to see the next question. The ratio of permissible shear stress in limit state. So, permissible shear stress in limit state method of design and working stress method of design. Permissible shear stress. So how you can work out the permissible shear stress of concrete? So permissible shear stress of concrete tau c with respect to permissible design shear stress of concrete in limit state method divided by shear strength of concrete with respect to working stress method, right? This ratio they are expecting. Permissible shear stress of concrete in limit state method, if you see it, we can give it, the formula as advocated by IS 456 is 0.25 times of root FCK, whereas the permissible shear strength of concrete in limit state method as per working stress method is 0.16 times of root FCK. So based on this one, these are the two things that were advocated by IS 456. So in such case, directly you will end up with the ratio of 25 by 16, isn't it? Or not? So directly you can pick option C itself is the correct one, right? Is that okay, brother? Right. So can I move to the next question, brothers? Right? Okay, moving to the next question. I hope you are able to see this question. Okay. The contribution of bent up bars. Two words. I hope you know the bent up bars. When you take this beam, bars are bent from tension zone to compression zone. Why the bars are bent up from tension zone to compression zone? Because especially at the end, these bent up bars are happening, especially at the supports, generally to increase the shear strength. So the contribution of bent up bars towards shear resistance shall not be more than to take total area of shear reinforcement. To take total area of shear reinforcement. How the shear reinforcement can be provided, brother? The shear reinforcement can be provided in the form of number one, vertical stirrups, number two, inclined stirrups, number three, I can say the bent up bars. Okay, right? So if you take the total shear reinforcement, out of total shear reinforcement, 50 percentage of the maximum at max, the code says generally by using with the help of only this bent up bars, total shear force cannot be resisted. So in such case, from the fundamental testing, only or exclusively with the help of bent up bars, the total strength is total shear strength will not be contributed. At max, I can say 50 percentage of total shear reinforcement can be designed with the help of this bent up bars. So using bent up bars alone, at max 50 percentage of total shear reinforcement can be designed, but the remaining 50 percentage of shear reinforcement can be designed by either vertical stirrups or by inclined stirrups, the remaining 50 percentage of shear reinforcement. So because the test shows, why it is the reason, the tests have shown tests have shown that inclined bars alone doesn't provide a satisfactory solution to resist shear, and therefore their contribution is limited to 50 percentage, and therefore pentabar's contribution is limited to 50 percentage to resist shear, to 3 percentage to resist shear, right? So the remaining, I already mentioned, the remaining shear reinforcement can be provided with the help of this vertical stirrups or inclined stirrups. Out of vertical stirrups and inclined stirrups, the best one I can say in terms of stability is vertical stirrups. I generally recommend all my brothers to do the reinforcement design with the help of vertical stirrups. Inclined stirrups are good in resisting shear, very good. But the problem with inclined stirrups is they are not stable in the formwork. When they are not stable in the formwork, even though it is good in resisting, and they are not stable, it is not good, right? So that's the reason why I recommend all my friends to do the shear reinforcement by using this vertical, right? So I can say here the option is directly A. Is that okay, brothers? Is that okay? Can I move to the next question? Right? So moving to the next question. I hope you are able to see the next question. If the nominal shear stress, okay, which is tau v at a section does not exceed, if tau v is not exceeding, that is tau v is less than tau c, okay, less than or equal to tau c, not exceeding, tau v is less than or equal to tau c. In such case, what is the thing that generally I need to provide it? So in such case, the section is safe in shear. Section is safe in shear, but still I need to provide some nominal or minimum shear reinforcement. But still need to provide nominal or minimum shear reinforcement. Why I need to provide still some minimum reinforcement, brother? Right. Why I need to provide still some nominal shear reinforcement? Because the shear strength can be taken by concrete alone, but still why I am providing? I can say like a minimum reinforcement why you need to provide is to take care of secondary effects. Take care of secondary effects like stresses due to shrinkage, creep, stresses due to shrinkage, creep, shrinkage one, creep, I can say. The third one is strength stresses due to temperature. All these things are not primary ones. These are secondary stresses. So these effects are not generally considered during the time of analysis. So in order to take care of even these stresses, some minimum reinforcement should be provided, especially if when tau v is more than 0.5 times of tau c and less than or equal to tau c. In such case, the crack can get initiated because of this shrinkage, creep, and temperature stresses. So that's the reason why we need to provide that. So coming to this one, the answer directly we can keep is minimum shear reinforcement is still provided. Yes, I need to go for this option, right? So moving to the next question, brother. Shall I go to the next question? Moving to the next question. I hope you are able to see the next question. The minimum cover in a slab I hope if you take a slab, what is the minimum cover instance? They are not mentioning clear cover. They are not mentioning. Na? In such case, I need to consider it as minimum clear cover. What is the minimum clear cover in slab? Should not be less than the diameter of the bar. So maybe if the cover should not be less than uh, diameter of bar, and clear cover should not be less than how much millimeter, should not be less than 15 millimeter. I can say when diameter of the bar is less than or equal to 12 millimeter, and clear cover should not be less than 20 millimeter when diameter of the bar is more than 12 millimeter in slabs, right? This minimum cover is to take care of durability issues. Okay, so I can say like directly the option is here. I can say B for Boston is the correct option. Na? I can directly deal with this answer as 15 millimeter, right? Can I can I move to the next question? Moving to the next question, bro. I hope you are able to see this question. The average permissible stress in bond for plain bars in tension. So the average permissible stress in bond for plain bars in sense mild steel bar in tension is. So average permissible stress in bond for plain bars in tension, how it can be? That is the question they are expecting. That is the thing. Average permissible stress in bond for plain bar. We call it as tau BD. And compared to tau BD, the average permissible stress for bars in compression. When compared to in compression, if tau BD is the bond stress of mild steel bars in tension, then what is the permissible stress of bond for mild steel bars in compression? In compression, the bond strength of the bars will be increased. So coming to the bond strength of the bars, I can say 25 percentage tau BD is increased by 25 percentage. So in such case, 1.525 times of tau BD is the bond strength of bars for mild steel bars in compression. So coming to HYSD bars in tension, when compared to HYSD mild steel bars in tension to HYSD bars in tension, HYSD bars has got, I hope you know HYSD bars, high yield strength reformer bars. This has got these rings. So because of these rings can adhere to the surrounding concrete where the interlocking is very good. In such case, the uh, bond strength can be increased by 60%. So I can say 1.6 times of tau BD. And let us suppose in case of HYSD bars, and HYSD bars in compression, and HYSD bars are in compression, in such case, we can call it as 2 times of tau BD. Again, I can say how I can say this 2 times of tau BD. This is already 1.6 times of tau BD, HYSD bar in tension. So HYSD bars in tension must and that permissible bond stress must and should be increased by 25 percentage. Na? So it is 1.6 times of tau BD into 1.2 is how you can mention. So here they are expecting the how this permissible bond stress in compression has got increased. In compression, it has got increased by 25 percentage, right? So I can say definitely like option B itself is the correct option. Is that okay? So shall I move to the next question, brother? Moving to the next question. I hope you are able to see this in this question. when shear stress exceeds the permissible limit in the slab. I hope when shear stress, okay, permissible, uh, okay, when I can say when shear stress, when developing shear stress tau v is less than permissible limit of slab, maybe I can say k times of this tau c. In such case, when limit exceeds na exceeds when tau v is more than k times of tau c. In such case, you can understand like shear generally in case of beams, generally we need to say like, sir, the shear reinforcement is to be provided. Okay, generally in beams, if it is in beams, maybe if I take k, tau is greater than tau c, either we can say like shear reinforcement is provided in beams, but here they are saying in slabs. If in slabs, generally we are not able to provide the shear reinforcement. In such case, to tackle this condition so that tau v is less than tau c, in such case I can say like I need to increase to make this condition safe. Generally in such case I need to increase the depth. Then in such case, increase the depth of slab, increase the depth of the slab. How I should increase the depth of the slab? Such that tau v, which is equal to vu by bd. When I increase the depth of the slab, this tau v is such that tau v will get reduced. That means developing stress will get reduced, and the tau v will get reduced so that tau v is less than tau c. In such case, like that, whenever there is a problem with respect to, whenever you are able to see a shear failure, especially is possible in case of slabs. Generally, to avoid that shear failure, we need to increase the effective depth of the slab. That's what is the big. But in case of beams, we can avoid that shear failure by providing shear reinforcement. So directly in case of slab, I need to increase the depth. So this is how we can deal the reinforce shear design in case of slabs. So in case of slabs, we need to increase the depth to reduce the shearing stresses. Whereas in case of beams, we can increase the depth of the section, or else we can provide the shear reinforcement. Providing the shear reinforcement is the better option in case of beams. So can I move to the next question? Right. Moving to this next question. I hope you guys are able to see this question, na? Right? The flexural shear crack. Okay, the flexural shear crack in reinforced concrete beam. If you take a reinforced concrete beam in this, is how the reinforcement. Flexural shear failure in reinforced concrete beam. Take a reinforced concrete beam. Flexural shear failure in a reinforced concrete beam. Flexural shear failure in reinforced concrete beam. So I hope you are able to see this. This one, maybe if I want to say, flexural shear failure in reinforced concrete beam occurs under large bending moment and less shear force. Yes, this flexural shear failure. Flexural shear failure is possible generally where bending moment is high and where the shear force is less. Where I mean, and less shear force. In such cases, this flexural shear failure. What is this flexural shear failure, brother? Flexural shear crack. Generally, this flexural shear crack, is not shear crack. I can say flexural failure in reinforced concrete. Flexural failure in reinforced concrete beam. When this flexural failure in reinforced concrete beam will occur, the flexural failure in reinforced concrete beam will occur at points of maximum bending moments, and where the shear forces is less, this flexural failure will occur. Okay, this first option itself is correct, no doubt. And where this flexural crack will occur, if you take this flexural failure will occur at maximum bending moment points. If I take this as uniformly distributed load, this is how the bending moment will be. The bending moment is maximum at the middle section. If I take a small, if I take uh, this is the bending moment diagram, and if I want to show the shear force variation, this is how I can say shear force variation. Now at this mid span here, if you take, bending moment is higher whereas shear force is low. So here the shear stresses are zero at this section, only bending stresses are there, and the bending stresses are maximum at extreme layer. Now, so if I take an element here, how the flexural crack will be. The flexural stresses are generally normal stresses. Now, this is how the stresses are there. So, because of this principal tension here, generally I can say like the crack will go in vertical direction because of pure flexural nature. So because of this, uh, the flexural failure in reinforced concrete results in cracks which are normally at 90 degrees with the horizontal. Yes, this is how the crack is with respect to this horizontal. The angle is at an angle of 90 degrees, right? I can say this is 90 degrees. I mean to say first and the second options both are correct. So coming to first statement and second statement both are correct. So coming to the third statement, I hope can you see the third statement, brother? So coming to the third statement, they are saying flexural failure in reinforced concrete beam occurs when span to effective depth ratio is less than one. So when span to effective depth ratio, which is nothing, when shear span to effective depth, maybe we can call it as shear span to effective depth ratio is A by D. Let us suppose. What is this shear span, brother? So generally, I can say if I take a beam in this, 2 point loads were applied, and this distance is nothing but shear span. How we can define the shear span? Span in which the span in which shear force is a non-zero constant value. How the span in which the shear force is a non-zero constant value. uh, Such type of span is nothing but shear span. In the shear span, bending moment need not be zero, but the shear force must and should be a constant shear force within what span. That span is nothing but shear span. Let me write that definition. Shear span, span in which shear force is a non-zero constant value. Such span is nothing but this shear span. In our present example, this A is the shear span. So based on this A by D ratio, different types of failures will be evaluated. Different types of failure will be observed in laboratory. So coming to this A by D ratio, I can say like for diagonal compression failure, I can say flexural failure, I can say when A by D is more than 6, then you can see this flexural failure. Flexural failure is possible in laboratory. But here they are saying occurs when when a shear span to effective depth ratio is less than 1. No, when it is more than 6, then only this flexural failure is possible. That means option 3 is a wrong option. Right? So I can say which of the statements are correct. What are the correct statements out of these three statements? First statement and second statement are correct. Na? So I can say directly like option A itself is the correct one. Right? Some people will say like, sir, there are other types of failures are also possible. Na? For what shear span to depth ratio, other types of failures are possible. Let me write that. Yes, let me erase all the. I just want to say when shear span by depth ratio, when A by D, which is equal to shear span by effective depth. When shear span by effective depth is ratio is equal to 1 to 2.5. In such case, diagonal compression failure is possible. Diagonal compression failure is possible. I can say when next one is when A by D ratio, shear span by depth ratio is between 2.5 to 6. In such case, it is diagonal tension failure is possible. I will show this diagonal compression failure and diagonal tension failure just after these questions are over. Na, I will show how these cracks will come and everything we will take care. Don't worry. When A by D ratio is more than 6, in such case, flexural failure. These diagonal compression failure, diagonal tension failure, these are the type of shear failures. From 1 to 6, I can say shear failure is possible. Or shear failures, right? When A by D ratio is more than 6, then flexural failure is possible. Okay, so I can say like option number 1 and 2 are correct. So I can say A is correct. There is no shear. Flexural failure is possible for 1 and 2 condition. For statement number 1 and for statement 2, I can say option A is correct answer. Can I move to the next question, brother? Moving to the next question. I hope you are able to see this next question. But critical section for shear in case of flat slabs. If you take what are flat slabs? Slabs that are supported on columns without beams. Such type of slabs are nothing but flat slabs. Slabs directly resting on columns without the support of beams. Without the support of beam. Such type of things are nothing but flat slab. In flat slab, where the critical section for shear, where the shear failure is possible. In case of flat slab, I can say this is a slab. Okay, this is the column. So in case of flat slab, the major failure of shear that is possible is two-way shear. I can say punching shear failure is the problem. Shear failure. The shear. What is punching shear failure? The other name for punching shear failure is also called as two-way shear failure. Two-way shear failure. Where that location of two-way shear failure is possible from this from the face of this column, I can say from the face of this column, the critical section for two-way shear failure will occur at a distance of d by 2, effective depth by 2 from the face of the column. I hope you are able to see here and here, right? So how it can look like, I hope it is very simple. Let me elaborate you. This is a mask, for example, right? Maybe this is a mask. If this is take this mask as something like a slab. This is column. So when this what do you mean by two-way shear means? So because of this because of this effect of this punching, this slab will go down and this column will come up in this way. I hope you are able to see this type of failure where the column is coming up and where the slab is going down. This type of failure here, it is happening clearly. I hope you are able to see this is happening clearly in both the directions, in longitudinal direction and width direction also. The shear effect is happening. This type of failure is nothing but punching shear failure. So I hope in our words, how we can mention is that critical section for shear, two-way shear will happen at a distance of d by 2 from the face of the column. So I can say d by 2 from the periphery of the column or capital drop panel. Yes, here I am showing only column. When the column is resting on the on a drop panel, I can show even drop panel also from the drop panel or from the column face. The critical section for shear will happen at a distance of d by 2. Yes, I can say like option B itself is the correct option. Is that okay, brothers? Is that okay? Right? Right. This is about two-way shear failure. If it is critical section for one-way shear failure, if they are saying like for one-way shear failure, in case of slabs, generally two-way shear failure is possible. But whereas in case of footings, there is a chance of one-way shear failure. In beams, one-way shear failure. In case of beams, I can say, case of beams, I can say when a beam is supported on a column, okay, the critical section for shear will happen at a distance of d from the face of the column. Distance of d from the face of the column. This is the critical section for shear. What is critical section? What do you mean by critical section for shear? It is the section where shear failure is possible. Is critical section for one-way shear in beams. This is beam. This is a slab. This is one-way shear. Here this is two-way shear. Another name for two-way shear or punching shear. Is that okay, brother? Shall I move to the next question? Yeah. So moving to the next question, brother. Right. In a reinforced concrete retaining wall, if you take a retaining wall which will retain the earth backfill, shear K is provided. When the shear K, if you take a retaining wall, maybe I can say the retaining the back is completely filled with the soil. I hope completely filled with soil. When this retaining wall generally is kept in this way, when this retaining wall is this is backfill, and the retaining wall is a failure in terms of shear, and then when the retaining wall is failing in terms of shear failure because of sliding, I can say sliding. If sliding failure is happening in retaining wall, so how that sliding failure can be stopped? I hope this is already beneath the ground, na? Maybe I can say this beneath the. So in case if sliding failure is happening in retaining wall, in such case, the best way to resist that sliding failure is by using a shear key. With the help of a shear key, which is just like this is a beam, with the help of this is shear key. If I design the shear key, providing a shear key in retaining wall will make the retaining wall safe against sliding. Will make retaining wall safe against sliding. So if this retaining wall needs to move in this way, that it move, this lateral this movement in this direction is stopped by this shear key, because the shear key is embedded inside the ground, right? As the shear key is embedded inside the ground, I can say like this horizontal motion from left hand side to right hand side is stopped, right? So I can say like retaining wall is uh, in a reinforced concrete retaining wall, a shear key is provided. If the retaining wall is not safe against sliding, then only we will provide to make it safe with respect to sliding. So moving to the next question, bros. Is that okay? Shall I move to the next question? I hope you are able to see the next question. Minimum shear reinforcement in beams. I hope you know minimum shear reinforcement. The minimum shear reinforcement in beams is provided in the form of. So generally, the minimum shear reinforcement is provided in the beams in the form of stirrups. For what? What this shear reinforcement will resist? I hope you know the shear reinforcement will resist principal tension. I just want to show you how this principal tension is resisted by this minimum shear reinforcement in beams. Okay, one second, let me explain you how. In tension zone, when principal stresses, when principal tensile stresses reach the tensile strength of concrete, by the time this by the time this principal tension failure is possible. For example, if I want to convey you, like, if I take a beam, for example, this beam is loaded with UDL. Okay, let me take with the help of UDL, right? Now I can say, like, uh, because of this simple support beam subjected to UDL, the shear force is small, where the shear force is small at the middle span and bending moment is large at the mid span. So if you take at the mid span, at this span, at this mid span, I can say mid span, shear force is small or zero, but bending moment is large. When bending moment is large, in such case, definitely I can say the bending moment is large, especially at the extreme ends. Because of this bending moment, bending stress is more, normal stress is more at this end. Okay, so because of which here the direction of principal stress is flat. This is the direction of, this is the principal stress here. Because what is principal stress? It is a maximum normal stress. The maximum normal stress is possible at the midspan, which is at the extreme layer, right? So I can say this is called as stress, principal stress. And when this principal stress reaches the flexural tensile strength of concrete, then definitely the crack will get initiated, right? So when the principal stress reaches the tensile strength of concrete, uh, this cause will cause flexural cracks nearly nearly vertical to the axis of the beam. If I take this is the axis of beam, to the axis of beam. These are initiated. I can say these flexural cracks are also, these are initiated even. I can say these flexural cracks are initiated even uh, when these flexural cracks are initiated even when the developing stress is between 50 percentage of shear strength of concrete to 1 times of shear strength of concrete. So when 0.5 times of tau c is less than tau v is less than tau c. In this case also these flexural cracks will get initiated. So even in this case, why in this case also why the flexural cracks are initiated, I can say because of secondary effects, I can say due to due to secondary stresses. Even in this condition also the flexural cracks will get originated, will get developed. So this minimum reinforcement is provided in the form of stirrups, I can say, to prevent flexural cracks, to prevent flexural cracks due to principal tension, to prevent, cracks that are coming due to principal tension. So that's the reason why we can say that. So can I move to the next question? Right? I hope you are able to see the next question. How can shear strength be ensured in a beam? How we can ensure, how we can increase the shear strength in a beam? How how shear strength can be ensured? Ensured in sense how we can increase the shear strength in a beam. Please, in a beam. How the shear strength can be increased in a beam in case of by providing binding wire on main bars. If this is the main bar, by providing binding wires on the main bars, can I increase the shear strength? No. Right, by providing main bars I can say like flexural strength can be increased by providing HYSD bars instead of mild steel bars. Can I increase this shear strength? We cannot say that one, but I hope you can say like uh, cannot by providing HYSD bars instead of mild steel bars. How can shear strength can be this is somewhat correct. How I can say that one? By providing HYSD bars by bending by if I just provide the HYSD bars, shear strength cannot be increased. The shear strength of the bars, the shear strength of the section can be increased by providing HYSD bars when they are bent up. Is there any bent up for was there anything was mentioned as HYSD bars were bent up? There was nothing was given like the bars were bent up. So I cannot even take this option B, because when these HYSD bars are used, when they are bent up, then the shear strength of that beam can be increased definitely. So I cannot even pick this option B. This option B I can pick when these HYSD bars are used, when they are bent up, then I can say like the shear strength of the beam can be increased by providing rounded aggregates. I think by providing rounded aggregates, I can say workability can be increased, not the shear strength of the concrete can be increased. No, these are wrong one, right? By providing stirrups, yes, by providing vertical stirrups or by providing inclined stirrups, the shear strength of the concrete can be increased. Yes, yeah, definitely it's D for Detroit is the correct option, right? So I can say 92D is the perfect answer, right? So for today, we completed all the limit state of shear, brother. All the clauses we had completed, and I had shown this theory. I had already completed in the same channel. This is theory. For that, I had already completed this theory in the same channel in limit state of shear. I had taken three to four parts for limit state of shear, like 8 hours I had taken on limit state of shear in the same channel with the help of theory and numerical problems also I completed. But this intention behind this lecture is so that we are tackling the clauses. All the clauses in shear we had completed. This is how the theory, this theory I had already completed in the same channel. So please excuse me. I am directly moving to the session end. Right. I just want to convey one thing. Every day, I just want to convey one thing. If you are a serious aspirant of GATE or ESE or any other competitive examination, then definitely I can recommend you guys to take the paid course. When you had taken the paid course, each and every topic will be taught to you in detail without compromising in the number of hours. And I can say, if you want to take the paid course for 12 months duration per plus course, the cost after 10% discount is 27,225. If you are a student of third year or second year, then definitely I can recommend you to take this 24 months course. The cost of this 24 months subscription course is 39,600. I can recommend this course for the students who are in third year and second year. Now, some people will also ask us, sir, is there any referral code is there so that we can get discount? Yes, by using this referral code written, you are going to get 10% discount on all the courses in an Academy Plus platform, right? And I just want to convey one more thing before I wind up the session. Every day, my class is happening in this Let's Crack GATE and ESE Civil YouTube channel. My class is happening by 11 a.m. And I can also recommend Kamalakar Pandey sir class also to you. His class is happening in this rankers batch by 9 a.m. every day. So I can recommend guys, like if you are a serious aspect of GATE or ESE or any other competitive examination, please take use of this channel. And last but not least, you are getting all this for free of course. Please share our videos to your friends. So please like our videos. If you are able to like our videos and share our videos, with more energy we can do more free content for you, right? And one more thing I can say is, please don't forget to press the bell icon. If you press the bell icon, the future coming videos of us will be notified to you. In such case, you will not miss even a single video. For you guys especially, I started a telegram group. This is Let's Crack Gate and ESC is one telegram group. And personally I had started another telegram group, which is Unacademy underscore civil engineer Tilak. Using these two telegram groups, you can join these two telegram groups with the help of this link which is given below. So if when you come down to our telegram group, you will not miss even a single video. Moreover, your doubts will also be resolved. So if you want to take, moreover, I just want to convey one more thing. If you want to take the paid course, don't forget to use this code VD10. When you use this code VD10 directly, it shows your trust on me, shows your faith on me. It will directly connect between you and me. And moreover, you are going to get 10% discount on any course from 6th standard to PG standard. Any course in an academy, you are going to get 10% discount. Okay. So thank you very much. Thank you. End of the session for today. Right. Please like our videos. Please like our videos, share our videos, subscribe to our videos. Thank you very much.